across much of the southern These rocks were originally reclaimed.
Is that as far as it goes?
They were then squeezed by massive forces, crumpling the rocks into folds and creating mountains. Mountains were there over the way of great sandstone. This land uncomfortable. From my observations of Sydney, I was
Sanity! I don't remember telling you to move. Here! Look at her. Do you hate yourself? You want me to stand there, will you? What's that?
I'm just going to take the chair and take it forward. That's just
Why is that quiet? Keep running off so you know what you're about.
No, I speak unto you. Do not grab that. No, you can't get there.
It's like a passion.
The famous transform books in the world is the 7 times 4. A slice of cardboard.
No, that's just a smaller size, so like you can see how big it looks.
It is anything, it is everything. This is the Big Bang.
Universe age 3 minutes.
The universe has expanded rapidly and is incredibly hot and dense. The first matter is beginning to form.
Universe age 380,000 years.
Hydrogen nuclei are combining with electrons. The first complete atoms have formed and light is starting to travel freely throughout the universe.
Universe age 200 million years. Switching screen to 21 centimeter wavelength.
The universe continues to expand and cool. In the blackness of space, gravity is forcing the hydrogen to collect and concentrate into massive swirling clouds, the first galaxies. Inside these young galaxies, something is happening that will light up the universe.
Universe age 1 billion years.
Pockets of hydrogen gas are collecting together. As their mass increases, they attract more and more hydrogen to form supermassive clouds of hydrogen gas. At a critical tipping point, the pressure caused by gravity forces the hydrogen nuclei at the core to fuse with their neighbors. The energy released creates a chain reaction through the cloud, and a star is born. Across the universe, in billions of galaxies, trillions of stars are igniting. These stars eventually reach a balance between the force of the nuclear reactions in the core pushing outwards and the force of gravity holding the star together. As the stars burn their hydrogen in a process called fusion, they create new elements like helium and oxygen. The largest of these early stars have very short lifespans, burning through their hydrogen in just a few million years. When the hydrogen runs out, the internal pressure drops and gravity takes over, collapsing the core. The collapsing material then rebounds in a giant explosion known as a supernova.
Gamma radiation warning. Closing shields. Unsafe levels for humans. Moving ship to safe distance. Universe age 3 billion years.
A supernova releases as much energy as your sun will produce in its entire lifetime. All the heavier elements in the universe, like iron, copper, and gold, are forged in these catastrophic events. Each explosion enriches a galaxy with a soup of new elements. Over time, they form clouds called nebulae. In a spiral arm of one galaxy called the Milky Way, something is growing deep inside a nebula.
New timeline. Solar system. Universe age 9.2 billion years.
A disk of gas and dust has formed. At the center, a dense cloud of hydrogen is about to ignite into a star you will one day call the Sun. In a rotating disk that surrounds the newborn Sun, material is starting to clump together to form blocks of rock and ice. Close into the young Sun, rocky materials are plentiful. Here, the planets Mercury, Venus, Mars, and your own Earth are forming.
Universe age 9.3 billion years. Earth age 0 years. New timeline.
Mountain-sized blocks of rock and ice continue to rain down on Earth for millions of years. They carry the water that will eventually form the Earth's oceans.
Prepare for descent to planet surface. Closing shields. Braking sequence initiated. Time jump path locked and correct. Altitude 10,000. 5, 4, 3, 2, 1. Landing confirmed. Earth age 2 billion years.
As the Earth cools, moisture in its atmosphere condenses, and it begins to rain. Every water molecule contains 2 hydrogen atoms, each formed when the universe was young. There is also one oxygen atom, forged in the heart of a star. Water is the molecule on which all life on Earth depends. The Earth is now cool enough for you to leave the ship. Enjoy exploring this dynamic planet time travels.
Spread, they also grew in weight and power. Flowing at the pace of the hour hand of a clock, a glacier reshapes the surface of the land beneath. A yawning crevasse exposes the structure of a glacier. The dark layers hold rock fragments, debris torn from the ground. Rocks that have become the teeth of the glacier, grasping at the land, fashioning its contours with immense power. A gigantic natural sanding machine, a glacier scours and carves deep valleys, leaving mountain ridges behind as signposts of its passing. As though hungry for rock, tongues of ice lick the valleys into shape, ripping rocks from the sidewalls and engulfing them in ice. Held at the glacier's edges, this huge mass of hidden debris is dragged along, grinding at the bedrock and further eroding the valley. two smaller glaciers merge, debris gathering along their edges forms a rocky ribbon in the middle of the new, bigger glacier. At the tip of the glacier, where its leading edge finally melts, huge ramparts of debris build up, heaps of eroded rocks liberated from the ice. Trapped behind such ridges, meltwater may form a lake. The retreat and advance of glaciers during successive ice ages has left a crumpled blanket of debris across many landscapes. When ice first relinquishes its grip, the ground revealed has been roughened by the glacier's work, leaving deep valleys bounded by rocky scree and cradling mountain lakes. The rock, a further powerful erosive force. Water can move mountains, weighing them down, sifting and sorting rock fragments by size. The fine grains ground out within the glacier melt out of the ice, turning glacial rivers milky as they start their journey to the sea. Shaped by glaciers which melted 10,000 years ago, the Scottish landscape has been softened by time, matured by the weathering of the rock and the growth of plants. But the arêtes and pinnacles of these majestic mountains are unmistakable creations of an age of ice. Landscapes are always changing. Ice, wind, and water are relentlessly at work. Polished Highland rocks, scarred by a moving glacier, are dramatic evidence of such timeless forces. A river, heavily laden with sand, silt, and gravel, creates a new landscape of floodplains, marshes, and mudflats. The material of mountains washes into the sea. Currents and tides shape and reshape the sediments into beaches, and waft the finer grains offshore into deeper waters where they settle and compress, turning slowly into rock, from which mountains may once more be built. It was here, in the oceans, that life began on Earth.
For the polar bear, the world's largest marine animal. This animal is exquisitely adapted to a life on the sea ice, hunting seals. It remains here throughout the winter, a solitary hunter roaming great distances.